Hey buddies, how are you doing? I hope you're doing fine these holidays. And I guess that you'll also be programming some stuff, right? Just like me. Okay, so this is it. I would like to discuss some stuff today about this menu screen that I have here in this code. So remember that our menu screen right now is like this. We have this person start. Of course, this is not the final image, the final sprites that we will be using, but just we are implementing the logic. The art will be put on top of it later. So right now we have this press start button, then we can choose the different characters, up to now just a couple of them. And then we can choose the time of the race. Once we have this, the race starts and that's it. However, right now the implementation is done in terms of an internal variable called state, which is here. And this state variable can have different values depending on the phase of the menu that we are. So first, when the state variable is 1, that means that we are in the press start phase. Then if the state variable is 2, then that's when we are choosing the characters. And when the state is 3, that means that we are choosing the race time. This is for very simple menus, this could be a way of implementing this, but if you plan to scale the game, if you plan to add new menus, I don't know, maybe for choosing different languages or for choosing different graphical settings, this is not a scalable solution, and it's kind of a messy way of hard code the different states. So yeah, you can see here that, for instance, during the loading of the menu screen, we have to load in advance every possible submenu that there is. And also for the draw and update methods, we need to check in which state we are, and depending on the state, we apply one or another logic. And well, as I mentioned, this could be a way of sorting out this problem, the menu navigation problem, in cases where we have very simple menus. But if we want to add further stuff, it's not the best approach ever. Not for sure. So just in terms of UML, or well, in terms of design, what we have right now is this. So basically we have this menu screen with a state variable, and for every function we need to check the state value. And what I intend in this video and the next videos to come is to change into this. Okay, so basically what we have now is that the menu screen has a state manager, and this state manager is in charge of handling the different possible menu states that we are going to traverse. And in the end, this is an implementation of a finite state machine, and these finite state machines are very useful not only for menu navigation but also for the artificial intelligence of enemies, which is actually the way that most artificial intelligence is actually implemented in most games. In order to better understand how these finite state machines work and how you can implement them in efficient and effective ways, I advise you to take a look at this very nice book called here Programming Game AI by Example, where you have a chapter, several chapters where they discuss the state machines, and it's very a very interesting read. So now the scheme would be as follows. Now we want the menu screen to have a state manager, and this state manager will have a state stack, which will have the different the previous states, menu states that we have traversed. And this state manager has also an owner, which in this case is the menu screen itself. And the idea of having this owner is that the state manager can forward this owner to different states, and these states can use attributes of the owner I don't know, for instance, maybe the dimensions of the screen in order to decide where to draw stuff. Also, this state manager, of course, have the current state, which is the state that is currently displaying and active in the game. And it has these different functions, draw, update, and change state, which basically are basically delegated to the different states. So each state has a load and draw and update function, and each concrete, this is a, well, this we can consider it as a base class, and each concrete state will override the load, draw, update to its own needs. This is a much cleaner and organized way of determining how we're going to traverse the different states. So now what we're going to implement is just the stack and the state manager. We will complete the implementation in other videos, and also we will complete the implementation of the different states in later videos. But for now, let's implement just a simple stack that will hold the different states traversed by the player, and the state manager, which handles all the higher level logic of the menu traversal. So let's start a new let's start a new file. Let's call it manager state manager.lua, and let's call another one stack lua. Well, yeah, menu stack lua. We can rename later if we don't like these names, but it's just to move faster. So basically, the stack is pretty a simple data structure to implement in Lua. We basically start like this. We will return this stack. We're going to implement it in a different model, so different models can import it. New, whoops. And what we'll do is just to detect this. This is the way to create a new stack, and now we just need two functions. We want to push elements in the stack, which is pretty straightforward. So it's just this pop function, which basically we just remove the stuff that is passed as an implicit argument. And that's for the stack. You know, it's kind of straightforward to implement. If you have any questions about the implementation, you can leave me a comment and I will explain further details. Regarding the state manager, we start as usual. Well, no, sorry. Yeah. And now, yeah, well, of course, we need the stack here. So the first function is to create a new state manager. There are different ways you can create like objects or so in, yeah, you know that in Lua there are no objects, right? Everything is a table, but you get what I mean. So as we saw in the UML diagram, we have this state manager has a owner, which in this case we know it's the menu screen. We will call it menu screen for that reason. Also, we have this current state, which initially is nil, and we have this states stack, which we will, yes, simply create right now. And this meta table is actually the state manager. You know that set meta table returns the second parameter, and this is what we're going to return. So another function that is interesting to have for a state manager is to set the current state. We basically set the current state to the new state, and importantly, we have to load the current state. Okay, so we know that something that we need to implement for the state class, again, it's not a class actually, for the state table, is the load function. Another interesting function here is the change state. Oops, sorry, yeah, this autocompletion is not always as useful. What we have to do here is first we need to, when we change the state, we have to push the current state into a stack. Second, we have to unload the current state. Next, we need to change the current state to the new state that we have passed as an argument. And finally, we load it. Interestingly, we have to implement also, or we could use this method to go to a previous state, which is pretty straightforward, having a stack. So first we would unload this current state. We would change the current state by the last state that is stored. State stack, yeah, state stack pop, which is storing the stack, and finally we would simply load the new state. And now remember that we have these draw and update methods that each state has to override. So this table, the state manager table, just needs to delegate that functionality to the current state. So in this case, we have current state draw, and we are going to forward the owner, which is the menu screen in this case, the owner of the state manager, because the actual state might use some of the attributes of the menu screen. So we need to forward it in order to give access to that information. The thing is applicable with update, only that we have to add also the differential time of the last frame. And of course, we need to delegate as well every callback that we want each menu can use or can access. So for instance, if we are pressing a key, or we're releasing a key and we want the current state to be aware of that, we need to delegate also as well. So if we have this key pressed, we want the current state to be aware of it, and we just create callbacks for each menu state. Also we passed the owner. Sorry, here I just noticed a mistake. Current state, key released, key self menu screen. And I think that's for now. I think I'm gonna cut this video right now. You've seen that we are changing the way we are implementing navigation in the menus. Again, we had this before, a state variable, and we have changed to this scheme. We have implemented this state manager and the stack to implement the state stack. In the next video, we will see how we implement the menu state and how we inherit from this menu state in order to implement different concrete states that we are interested in. Well, that's all for now. See you in the next video, and happy programming.